Hello there, and welcome to Science for Sleep, where curiosity finds a quiet corner and science takes the scenic route to rest. Tonight's gentle journey begins under a sky that has held mysteries since long before we had telescopes. Long before cities dimmed the starlight, even long before anyone thought of words like physics or cosmology. Tonight, we're going to follow a trail into one of the most puzzling riddles of the cosmos. Not the kind of riddle you can answer with a clever line, but the kind that keeps scientists up at night and yet somehow soothes the imagination when you hear about it. We're going to talk about dark matter, the invisible something that seems to hold the universe together. Before we wander too far, I'd love to ask you something small, something simple. Where are you listening from right now? Are you tucked in somewhere cozy, maybe with the lights dimmed and the day finally put aside? Or are you on the other side of the world with the sun not yet set and you're sneaking a little time to yourself in daylight? It's funny, isn't it, that no matter where you are, you're still inside the same vast universe, drifting inside galaxies that themselves are floating in an ocean of something we can't see. That invisible ocean, if the science is right, outweighs all the stars, planets, and dust that we can see with our eyes. It's strange to think that when you look up at the night sky, the twinkling stars and glowing galaxies are only the tip of the iceberg. The rest, the far larger portion, is hidden. If you find yourself enjoying this slow exploration, if the idea of drifting through science at a pace designed not to rush you, but to keep you calm feels like something you'd like more of, it would mean a lot if you tapped like, maybe subscribed, or even shared this with someone who might enjoy a quiet space at the end of a long day. That helps this little channel reach others who could use a peaceful pause too. So, settle in. Slow your breathing just a little. Let the noise of the day fall behind you, because tonight we're going to begin following a mystery that has occupied astronomers for almost a century. We'll walk gently through the questions, the evidence, and the strange possibilities. Not in a hurry to reach the end, but happy to simply wander in the company of curiosity. Dark matter. A phrase that sounds like it belongs in a storybook about hidden forces or magical powers. But in truth, it is the name we've given to a puzzle that science cannot yet solve. Imagine for a moment that you're looking at a galaxy, a spiral of light, a glowing whirlpool of billions of stars, dust lanes like smoke spirals winding around a bright center. Telescopes capture these images for us and they're stunning. But there's a catch. If you calculate the mass of all those visible stars, all the gas and dust, you come up short. The galaxy spins too fast. The stars at the edges whirl around at speeds that should fling them off into space like children holding onto the outer rim of a merry-go-round spun too quickly. And yet, they don't fly away. They stay. The galaxy holds together. The only way it can, according to the math, is if there is far more matter there than we can see. Something invisible that provides the gravity needed to keep the whole structure bound. That something is what we call dark matter. It isn't dark in the way of shadows. It doesn't absorb light, and it doesn't glow either. It simply doesn't interact with light at all. Light passes right through it, or maybe past it as if it isn't even there, which is why it took so long for scientists to notice. But the gravity gives it away. Gravity is the one messenger it cannot hide from, and through that, we've learned that most of the universe is made of this hidden stuff. By most, I mean more than 5 times as much as the ordinary matter you and I are made of. Stars, planets, trees, oceans, even your favorite blanket. All of it together is a minority ingredient in the cosmos. The dominant one is this invisible material that we don't yet understand. It's almost comical in a way. Humans spent centuries cataloging stars, naming constellations, building telescopes to peer deeper and deeper. And only in the last century did we discover that what we can see is hardly the main story. It's like spending all day arranging the furniture in your living room, only to discover that your house is floating on an invisible ocean you didn't know was there. And the ocean is bigger, heavier, and more fundamental than the furniture you thought was everything. The first hints came in the early 20th century. Astronomers measuring the motion of galaxies inside clusters noticed something odd. The galaxies moved as though they were being held together by far more gravity than their visible stars could provide. Later in the 1970s, Vera Rubin and her colleagues mapped the rotation of individual galaxies and found the same thing. The stars at the edges circled too quickly. There had to be more mass than they could see. Rubin's careful observations made the case undeniable. Something invisible, something non-luminous was there. And it wasn't just a minor detail. It was the main ingredient. At this point, you might be wondering the same thing scientists have wondered for decades. What is it? Is it some kind of hidden particle? Something like the familiar protons and neutrons, but more elusive? Is it made of faint burnt-out stars, tiny black holes, or clouds of cold gas we can't detect? Or is it a sign that our understanding of gravity itself needs revision? These questions form the core of modern cosmology. And so far, the answers remain just beyond our reach. But before we dive into possible explanations, let's sit a little longer with the strangeness of it all. Because strangeness is sometimes the best place to rest for a while. You live in a universe where the overwhelming majority of matter is invisible. Not invisible in a trickster's way, but truly non-enacting with light. The atoms in your hand, the ones that make up your skin, your bones, your heartbeat, are part of the small fraction. You are luminous matter. You are the rare portion that glows under starlight. Everything around you that you can see or touch is part of this tiny minority. The rest of the universe, the silent majority, floats invisibly around galaxies, threading them together into vast filaments like cosmic spider webs. When you step outside on a clear night and see the Milky Way stretching across the sky, you're looking at the bright decorations on a much larger, darker framework. Without that framework, the stars would not even be in those positions. Galaxies would not form. Planets would not form. You would not be here to wonder about it. Dark matter in its silent, hidden way made the visible universe possible. The term itself, dark matter, is less a description and more a placeholder. It doesn't tell us what the substance is. It only tells us two things. It has mass and it doesn't interact with light. That's it. 2 clues. And from those two, an entire scientific enterprise has unfolded. Underground laboratories built beneath mountains to shield from cosmic rays, giant particle colliders smashing protons together at nearly the speed of light, telescopes mapping the distortion of distant galaxies as invisible mass bends their light. All of this chasing a quarry that has never once shown itself directly, and yet the evidence piles up in every direction. Galaxies, clusters, the large-scale structure of the universe. All of them make sense only if this unseen matter exists. Computer simulations of cosmic evolution run without dark matter simply do not produce a universe that looks like ours. But put in the invisible ingredient and suddenly the virtual universe resembles the real one with filaments and clusters just where we expect. It is as though we've been handed the recipe for the cosmos but are still missing the name of the main spice. Sometimes science is like that. You know something is there not because you see it directly, but because everything else points to it. Like hearing music in another room, you know someone must be playing it. Even if the door is shut, dark matter is the music behind the door of the universe. And we've been standing outside listening for almost a century now. So here we are at the threshold of one of the greatest mysteries in science, the invisible mass that outweighs the stars, the silent architect of galaxies, the substance that shapes the universe but refuses to reveal its identity. As we move forward, we'll follow the history of how we found it, the experiments built to detect it, and the strange possibilities it raises about the nature of reality. And perhaps as you listen, you'll feel the same odd comfort many scientists confess to, that even in the face of what we don't know, even in the presence of mystery, there's something steadying about admitting it. We don't have all the answers, but we have the questions, and the questions themselves are enough to guide us tonight. Let those questions be the gentle current that carries us forward. When you look up at the night sky, you see a canvas scattered with points of light. To the unaided eye, there are only a few thousand stars visible from even the darkest locations. Through a telescope, that number grows quickly, revealing that the sky is not sparsely decorated, but overwhelmingly filled. Each star we see belongs to our galaxy, the Milky Way, which itself is only one among hundreds of billions. From the Earth's surface, light travels across space to our eyes, and it feels natural to assume that the universe we observe is the universe that exists. After all, sight has always been our most trusted sense. We rely on it to move, to recognize one another, to navigate the world. So it seems intuitive that the stars and galaxies glowing in their brilliance represent the universe's contents. But the truth is, our eyes reveal only a fraction of what is really there. And that realization, unsettling though it may sound at first, is one of the most profound shifts in human understanding. The things we can see, touch, measure directly form only the visible tip of a much larger cosmic iceberg. Beneath that glowing surface lies something darker, something more substantial. The hidden matter that shapes everything, yet remains beyond the reach of our sight. For most of history, humans had no reason to suspect this imbalance. The night sky, though mysterious, seemed straightforward. Stars shone because they burned. Planets reflected sunlight. Comets stray briefly and then were gone. Everything visible could be explained by natural processes that, while not always understood, at least followed from the familiar principle that things make themselves known by light. If you couldn't see it, maybe it wasn't there, or at least it wasn't relevant to your daily life. That assumption worked well enough for centuries. The invention of the telescope expanded the boundaries of vision, but reinforced the same idea. Galileo's glass revealed craters on the moon, moons circling Jupiter, countless faint stars invisible to the eye alone. Later, larger telescopes revealed galaxies, nebulae, clusters. Each step forward in optics seemed to confirm that the universe was simply a larger and more varied version of what we already knew. The brighter your instrument, the more of reality you could capture. Seeing meant knowing. But in the 20th century, cracks began to form in that comforting belief. Astronomers who measured the motions of galaxies discovered that the luminous matter alone could not explain their behavior. What was visible, even when multiplied by billions, was not enough. The mass we could see was just a fraction. The invisible remainder had to be there, or the galaxies would spin themselves apart. To appreciate the scale of the problem, consider this. If you add up all the stars, gas clouds, and dust in a typical galaxy and use their combined mass to calculate the expected gravitational pull, you end up predicting a certain speed for how stars should orbit around the galactic center. Close to the core, where most of the mass is concentrated, the stars should orbit quickly. As you move outward, where less mass is enclosed, the orbital speed should drop. Just as planets in our solar system slow down as their distance from the sun increases, Mercury races around the sun in just 88 days, while Neptune takes 165 years to make a single orbit. That makes sense because gravity weakens with distance, but galaxies don't follow this pattern. Measurements show that stars far out from the galactic center orbit just as quickly as stars much closer in. It's as though the galaxy refuses to thin out. The outer regions, which should be loose and drifting, are instead firmly held. The only way to account for this is to assume that an enormous amount of unseen mass surrounds the galaxy, forming a vast halo that extends far beyond the glowing spiral arms. Without this halo, the stars would fly away. With it, the galaxy holds together. And so what we can see is not what really is. The luminous disk of a galaxy, beautiful as it is, represents only the visible decoration. The true mass lies in the unseen halo, enveloping the system in an invisible sphere of gravity. This realization is unsettling because it overturns our natural intuition. We are wired to trust vision. Yet vision, it turns out, is not a reliable guide to the universe's structure. It shows us only the minority component. Scientists now estimate that all the ordinary matter, the stuff made of atoms, contributes only about 5% of the total contents of the universe. 5%. That includes stars, planets, interstellar gas, intergalactic dust, black holes, and every atom in your body. The rest is invisible. Roughly 27% is dark matter, and about 68% is something even stranger called dark energy, which drives the accelerated expansion of the universe. But dark energy is a mystery for later. For now, it's enough to recognize that most of what holds the cosmos together is beyond sight. It is natural to ask how we know this if we can't see it. The answer is that science does not rely solely on vision. We measure by inference, by consequence, by the footprints left on what we can see. Light bends when it passes near massive objects, a phenomenon predicted by Einstein's general relativity and confirmed countless times since. By mapping how light from distant galaxies is distorted, Astronomers can create maps of invisible matter. They see vast regions where no stars shine, yet where gravity bends light just the same. These invisible clumps and filaments weave the large-scale structure of the universe, guiding the formation of galaxies and clusters like scaffolding beneath a building. In some regions, the evidence is dramatic. Take the Bullet Cluster, a collision between two galaxy clusters observed in X-rays and visible light. The hot gas, which should dominate the mass, lingers in one region, but the gravitational lensing indicates most of the mass lies elsewhere, separated from the gas. This mismatch demonstrates that something other than normal matter must be present, carrying most of the weight. Astronomers point to it as one of the clearest visual proofs of dark matter's existence. The contrast between what we can see and what we cannot also extends closer to home. Within our own Milky Way, the distribution of stars suggests an invisible halo that is 10 times more massive than all the visible matter combined. This halo stretches far beyond the disk, enveloping our galaxy in a spherical cloak of unseen mass. Though we move through it constantly, we have no direct sensation of it. It does not push against us, does not block the sunlight, does not interact with atoms in a way we can detect with our senses. Yet its gravitational influence is undeniable. The solar system itself is only a speck within this halo, like a small bubble suspended in a vast invisible ocean. To live in such a universe is to accept a humbling truth. What is visible is not what is dominant. We live in the minority slice, illuminated and comprehensible, while the bulk of reality remains hidden. This is not to say the visible universe is unimportant. It is, after all, the part that gave rise to life, to minds that can wonder, to the technology that allows us to probe deeper. But it is not the whole story. It is only the bright fringe of a much larger tapestry. The distinction between the seen and unseen also reshapes how we think about knowledge itself. For centuries, humans equated knowledge with sight. Phrases like, "I see," are synonymous with "I understand." Yet modern cosmology tells us that understanding often comes not from what we see directly, but from what we deduce indirectly. The invisible may be more fundamental than the visible. We are forced to acknowledge that sight is not the ultimate authority. Gravity is the motions of galaxies, and the bending of light reveal truths that vision alone cannot. This shift has practical consequences too. Modern observatories are not designed merely to capture visible light. They record X-rays, gamma rays, radio waves, microwaves, all of them forms of electromagnetic radiation that carry different kinds of information. Even so, all these forms of light together still fail to detect dark matter. It remains outside that entire spectrum, interacting only through gravity and perhaps faintly through forces we have not yet observed. And so the question grows deeper. What is this unseen mass made of? If it is not atoms, what is it? Theories abound, from exotic particles predicted by extensions of the standard model of physics to primordial black holes formed in the early universe. Each possibility comes with its own challenges. None has been confirmed. But before we wander into those possibilities, it's worth pausing again on the simple fact of how little we see. When you gaze at the night sky, you're looking at the 5%. The shining islands of stars are like lanterns strung across a vast invisible framework. The glow is real, the beauty undeniable, but it rests upon a hidden foundation. Without that foundation, the lights would not be where they are. It's an odd comfort in a way to know that we are suspended in something larger, something unseen yet dependable. It means the universe is more mysterious than it looks, but also more stable. The galaxies are held, the stars bound, the cosmic web stretched across billions of light years, all because of a presence we cannot see but can infer. When you think about weight, it's natural to imagine something tangible. A bag of flour in your hands, a suitcase that feels too heavy at the airport check-in counter, or even the reassuring pull of gravity when you sink into your favorite chair. Weight belongs to things we can hold, touch, measure with a scale. It is something that presses downward, something that makes its presence known. In everyday life, weight is always connected to matter you can see. But in the universe, weight has a much broader meaning. Gravity responds to all mass, visible or not. And in that sense, the cosmos is revealing a strange truth. The universe is heavier than it looks. Astronomers discover this not by chance, but by watching carefully. They studied how galaxies move, how clusters of galaxies behave, how light bends on its way across space. Again and again, the measurements reveal the same story. There is more mass than meets the eye. The luminous stars, glowing clouds of gas, and delicate streams of dust make up only a small part of the whole. Something unseen carries the majority of the weight, shaping the universe with its gravity. To appreciate the scale of this, imagine taking every star in the Milky Way, perhaps 400 billion of them, and adding up their combined mass. Now include all the gas between the stars, the clouds of hydrogen and helium that stretch for light years, as well as the dust that filters starlight and the black holes hidden in stellar remnants. When you tally all of that, you arrive at an impressive number, one that defines the visible skeleton of our galaxy. But when you compare that to the total gravity holding the Milky Way together, you find you're short by a factor of about 10. 10 times more matter is required to explain the galaxy's weight. That missing matter, though invisible, outweighs the visible by a wide margin. This is not a small correction or a minor oversight. It is not as though a few dim stars escaped the count or some hidden gas clouds went unnoticed. The discrepancy is overwhelming. The invisible matter dominates. It is the main contributor to the galaxy's mass. What we can see is almost ornamental compared to the vast halo of unseen material surrounding us. If you've ever tried building something, you know the importance of a good adhesive. A puzzle stays together with patience and careful edges, but a house, a bridge, even a child's paper craft often needs something that binds the pieces into one whole. In the universe, the stars and galaxies need that too. Left on their own, they would not remain the intricate structures we admire in telescope photographs. They would drift apart, the pieces scattering into the void. Yet they don't. They hold. Something acts as the glue, not a sticky liquid, not nails or screws, but a force, a presence. That presence is gravity. And gravity is strengthened, shaped, and given its full power by the unseen mass we call dark matter. To understand how essential this glue is, it helps to return to the simple idea of a spinning galaxy. Imagine a merry-go-round filled with children spinning faster and faster. The children near the center hang on easily because the pull toward the middle outweighs the tendency to fly outward. But those at the edge struggle. The faster the spin, the harder it is to hold on. Now scale that image up to something millions of light years across. Stars orbiting the edges of a galaxy spin at speeds that should hurl them outward into the blackness. Yet they remain orbit after orbit, generation after generation of stars bound by gravity that exceeds what the visible matter alone could provide. The invisible weight supplies the glue, and without it the galaxy would unravel. This glue is not unique to a single galaxy. It binds clusters of galaxies, the largest gravitationally bound structures in the cosmos. These clusters containing hundreds or even thousands of galaxies should be unstable if only visible matter counted. The galaxies move at speeds too high for the light we see to explain. But when dark matter is included, the system makes sense. The invisible halos around galaxies and clusters act like enormous cushions of gravity, keeping the luminous matter gathered and stable. The idea of a glue that holds the universe together is both simple and astonishing. Simple because the concept of a binding agent is something we encounter in daily life. Astonishing because in the universe that agent is made of something we cannot see or touch. It exists only through its gravitational influence. It does not shine, does not glow, and yet it is stronger than everything that does. One of the most remarkable demonstrations of this cosmic glue comes from looking at the early universe. After the Big Bang, the cosmos was a hot, dense soup of particles and radiation. Matter and light were coupled together, constantly scattering, preventing the formation of stable structures. As the universe expanded and cooled, light decoupled from matter, leaving behind the cosmic microwave background radiation. This ancient light still reaches us today, stretched into microwaves by billions of years of expansion. But embedded in it are tiny variations, ripples in temperature that reflect the dist,